Hello, Mr. Walter. You can look back at a long history in simulation technology and robotics. As a founding member of Visual Components, you wanted to create a simulation tool for the mainstream. Have you achieved what you set out over 15 years ago?
Not yet, but we're getting closer. And the reason why I say that is that simulation technology goes back quite a long ways. And the first people who were using simulation were using it not so much because they needed it, but because they could. These were very large companies with large resources that could afford these very large investments in both the computing system and large, expensive, complex software to be able to achieve some of the simulation results that they needed. The irony is, though, that it's the people who really need simulation are the small to medium-sized companies. And it's always been well out of their reach because of the complexity of the systems and the costs. And over the past 15 years, we've been moving closer and closer to that goal, in which now a lot of those companies that are very small can't afford it because the computing power has come down. Before you needed a very large mainframe, now the kind of power that used to exist in mainframes already exists in everyone's laptop, and in some cases even in their tablets. The other prerequisites has been that the software has been too complex in the past, and now it's getting easier and easier. So we've worked on the design interfaces, the GUIs, to make things plug and play, drag and drop, so it's very easy to take complexity and build it up out of some very simple objects. So this means it starts to become attainable within reach of these small to medium-sized companies. And I still think we have a little bit of work to go, but I'm pleased to say that we are getting very, very close, and our next generation products, I believe, will address that.
You co-developed the offline programming tool of Visual Components. What are the three main advantages customers achieve when using it?
Okay, one of the first things is that they're able to visualize something that they were not able to describe or show to anyone else. So you can take a 2D drawing and turn it into 3D. And then you have motion, and from that immediately you can communicate to others that these are the ideas that we have in place as a proposal. The other is, as you're running the simulation, you begin to see problems that you didn't anticipate. You had no idea that that was going to happen because of the complexity of the system. And sometimes it's a big surprise that you expected one result and you get something else. So that's one of the other benefits. And third is that once you have your layout or your model in place, you can now start to use it to begin to generate code and debug a lot of the code for your cell. That could be PLC logic, making sure it's working right, or it can be the robot code. So if you have a particular process, you can now not only simulate what the robot's going to do, but generate the program that you can download to it. That means the robot is ready to go. You don't have to program it on the floor. And the other is that there's a greater degree of precision and control that you have on the process. So for instance, you can start to take any sort of standards and methods that you use within the company and start applying those through programming templates to ensure that every time you create a new program, it's very much like the last one. So there's consistency in the process from one product to the next.
What is the next? Where do you see the simulation business going?
Okay, again, I see that we're going to have a greater democratization of simulation, meaning it used to be that only a few could afford high-end kind of simulations. We've brought the cost down, the technology down, but I still think it needs to be wider used. Most engineers are expected to have a certain toolkit already on their laptop that they bring with them everywhere, or their tablet. And usually you're expected to have some sort of maybe CAD system on there. You're expected to have some sort of office suite that would include word processing and being able to do PowerPoint or Excel spreadsheets. You're expected to have that. I believe the missing component is having simulation also available to every engineer who is working in this field. And in order to achieve that, you have to look at how was Excel able to do it? How were they able to take something very, very complex, that kind of technology, and make it available? Well, the first thing is they had to make sure the user interface was easy enough that you didn't need to have a PhD in accounting to figure out how to create a spreadsheet. So it was very obvious, easy enough to remember when you've gone on a break or if you don't use it day to day. And finally, the cost. It's within reach. So if you bring the cost down, you bring the complexity down, now everyone can start using it. Everyone can communicate from what we say, the shop floor to the top floor.
Thank you.
Okay, thank you.